Hi, in this video we're going to continue our study of functions and continuing with graphing piecewise functions. This one has 3 pieces. By now we should know how to graph a linear equation in quadratics. Today we're also in this video going to learn how to graph the absolute value of functions, so stay tuned for that. This particular function has 3 pieces, negative x, 9 minus x squared, and x minus 3. So when you look at piecewise functions, the first thing, or one of the first things that I would like you to think about is how are these fitting together in a graph? And so we look at the points where it's split. And so I call these the split points. So my split points are x equals -1 and x equals 3. So those are the ones where things are changing. So you can also call them changing points, I suppose. So when I draw my entire graph, the full graph, I'm going to be looking at, okay, so things are changing at -1, and then things are changing again at 3. So there's stuff happening to the left of -1, in the middle between -1 and 3, and then things are happening to the right of 3. And so this is where we're going to go look at the different pieces. And if it's helpful to draw them separately, as we did in the previous video, so if you haven't watched the section 2.1 video on piecewise functions, then I encourage you to look at that video first. So the first piece is y equals -x. So what does -x look like? So y equals -x is a line, I can't seem to draw straight, with the y-intercept at 0, 0, and it just goes through the origin with negative slope. So this is y equals -x. Now for this function, it says my split point, the point where I'm looking at, is x equals -1. So I'm going to go to -1 located on my graph. And what is that looking like? So when x is -1, this is the point, -1 comma -1, so it's -1, 1. So that's what that point is. So when x is less than -1, I want everything. So when x is less than -1, you're over here. So I want this part of the graph, not including the point -1, 1, because it doesn't have the equals there. And so now let's go look at the second piece. And if you feel comfortable going directly now to the main graph, I can say, okay, so at -1, 1, there's going to be an open circle because we're not including it, and then is the y equals -x line. Y equals -x. And so now for the middle part, 9 minus x squared, what does y equals 9 minus x squared look like? So this is a parabola. And if you need to still evaluate points, like a t-chart, to be able to see what this looks like, then go ahead and do that. Plug in values like -2, -1, 0, 1, and 2, and see what it looks like. But hopefully you're able to see, okay, this is a square, so it's a parabola. And it's a negative x squared, so it's a parabola that points downward, and with the y-intercept at 9. The vertex is at 9, and it's a parabola that goes, because of the negative x squared, this parabola opens downward. And so this is the middle section, so between -1 and 3. So I'm going to go to -1 and see what is the y value there. So plug it in. So if you plug in -1 here, you're going to get 9 minus a -1 squared. Well, -1 squared becomes +1, but you're still subtracting it. So when x is -1, you're going to have 9 minus +1. So that's the point there. And it does have an equal, so I will include that. And then my other split point is 3. So when x is 3, what does this look like? So I already saw that when x is -1, we get y is 8. When x is +3, what do we get? Y is going to be 9 minus 3 squared. So y will be 0. So it must be this point here. So this must be the point 30. So that means that for the middle piece, I want this part of the graph. And so we can, if you're comfortable, then you can go over here to the main graph and draw it. So at 9, and I know it only goes at 8 included. So at -1, it's 8. And sorry, I have my email on here. And at 3 is 0. And notice that when it says x is less than 3, this is not included. So at 3, we're going to have an open circle there. So this point on this graph is not included. So when we go to the main graph, it's going to be an open circle. And so now I'm going to graph my parabola. And so hopefully your graphing skills on the tablet are better than mine. But this is what our parabola kind of looks like. And then the last piece is the line y equals x minus 3 for when x is greater than or equal to 3. So we will get to include that one. So the third piece is the line y equals x minus 3. So x minus 3 on its own has a y-intercept of -3 and slope 1. So it goes something like that. And again, my split point is at 3. So I'm going to go when x is 3, what's y? When x is 3, y is equal to 0. So that's that point. And I want when x is greater than 3. So this point, including this point, including 3, 0. So just similar to what happened in the video for section 2.1, I'm going to go to 3, 1, or 3, 0, sorry, and we're going to fill that in, and then it's going to look like the line. So this is y equals x minus 3. And this one was y equals 9 minus x squared. So those are the three pieces that make the final answer. So this would be the graph of f of x. So that's our final answer. Some of you may be able to just directly go to the graph from the pieces from the function, and that's fine. And some of us may need to draw the individual pieces to then put it together. Now, the other thing about these piecewise functions is that they are functions. So you got to make sure that every input has exactly one output. And so that's why when they meet here, when we had left it open, we said not included for the parabola portion. We had left this open at 3. And then when we go back and fill it in with the green one, notice that then that makes it so that 3 only has one output, right? In order to be a function, every input has to have exactly one output. So if both of these were included at 3, that would mean that 3 would have two different outputs. So we've got to be careful about that. And the best way visually to see if something is a function is if it passes the vertical line test. So if you draw a vertical line anywhere on the graph and it only touches at one point, that means that the input only has one output. Otherwise, if you had multiple outputs, that vertical line will touch at multiple points. So you want to make sure that after you're finished graphing a piecewise function like this, that you attempt to draw like imaginary vertical lines and see, okay, am I touching at only one point? Yes. I know in the previous chapter, in chapter 1, we graphed circles. And so, for example, if I wanted to graph x squared plus y squared equals 4, what does that look like? and is it a function? So this is a circle with center at 0, 0. And what's the radius? The radius is equal to 2. So if we graph these, what we're going to get is pretend it's a nice circle, and center at 0, 0, and the radius will be 2. So it'll be 2 all the way around, so that will make this -2. This is not drawn to scale. And so this will be a circle. So is this a function? And the answer will be no, because if you draw a vertical line anywhere, right, it touches at 2 points. So this is not a function. It doesn't pass the vertical line test. Okay, so now let's graph the absolute value of x. So say I have f of x is the absolute value of x. And we can do it, I'm going to show you 2 ways of doing this. We can do by doing a table of values. And y equals f of x. Remember, y equals f of x. So f of x is just a fancy name for y. That's the value of x. So with the table values, I usually do, these are my standard values. I need some negatives, I need 0, and I need some positives, and see what I get. So when x is -2, y is going to be the absolute value of -2, which is 2. When x is -1, the absolute value of -1 is 1. Absolute value of 0 is 0, and so on. The absolute value of 1 is +1. Absolute value of 2 stays +2. So when I'm going to plot it, I can plot those points, right? So this becomes the point -2, 2. This becomes the point -1, 1. That's 0, 0. This is the point 1, 1, and then 2, 2. So when you plot them, notice that -2, 2 is going to be up here, -1, 1, 0, 0, and then you're going to go 1, 1, and 2, 2. So and this is not curving, right? The highest power here, or the power of this x, is x to the 1, so it has that linear term. So this is going to look like a line. But then it picks right back up there, it turns around, and it comes back. So on the absolute value looks like a V, and you may have seen that. So this is the graph of the function. Now the second way that you can do this is you can think of what the definition of the absolute value is. F of x equals the absolute value of x is actually a piecewise function. And when we think about the absolute value of x, notice that when we set the absolute value of a negative number, so when we said x equals -2, we said the absolute value of -2 is 2. So how does it make it positive? Well, you're giving me the opposite. Right? This is saying when x is a negative, give me the opposite. The opposite of a -2 is +2. The opposite of -5 is 5. So the way that the absolute value becomes a piecewise function is because we say, okay, if x is positive, we're just going to get x again, right? That's, if you get a positive number, the absolute value of 5 is just 5, so it stays the same. It's just when you get a negative number in there, so when x is less than 0, what are you doing, right? When x is -2, the absolute value of -2 is 2, so you're giving me the opposite. When x is -5, the opposite of -5 is 5. So when x is negative, we're getting the opposite of x, so negative x. So if you think about it, right, the absolute value of -5 is really -5. So that's what this is saying, which is +5. So now graphing it, so this is the definition of the absolute value. So when you look at the graph, you can see how that applies. So here's my piecewise function for the absolute value of x, and here's the graph. So notice that when x is greater than 0, so here x is positive, we look at the line y equals x. which is the line through the origin with slope 1. And because it says just when x is positive, so we're just taking that part of the graph, which is what we did here. So this is our y equals x. Now when x is equal to negative x, or when x is less than 0, sorry, so when x is negative, we are graphing y equals negative x. So what does y equals negative x look like? It's still a line through the origin, but the slope is negative. So it goes this way. And then when x is less than 0, we only want the left side of it. And so that's what this is back in this graph. It's hard to trace. So this is your y equals negative x. So together, they make up the absolute value of x. And so that's, you might see that defined for the absolute value as a function. This is a piecewise function. So f of x equals the absolute value of x is a piecewise defined function. Right, and just the definition is above, but I'm just going to rewrite it for clarity. So f of x is defined to be x if x is positive, and negative x, the opposite, if x is negative, x is less than 0. So just give yourself some values, right? So what I want you to do is pause and think, well, what is f of negative, I don't want to use negative 5 again. Say, what is f of negative 2? What's f of negative 12? And then find some positives. What is f of 17? And what's f of 7? So try those, see what you get.